Now see, experimentally we can observe these things. Suppose we have two different substances and we want to increase the temperature of both the substances from room temperature to 10 degree Celsius. Then amount of heat required, that will be different one. That will be different one. So from this one, the heat capacity is defined. Heat capacity is defined as the amount of heat required to raise the temperature of given substance by 1 degree Celsius or 1 Kelvin is called its heat capacity. Okay, and heat capacity of the substance, that depends on the type of the substance as well as the amount of the substance. Suppose delta Q amount of heat is supplied to the substance and due to that its temperature is increased by delta T, then we can write the heat capacity of that substance, that is delta Q by delta T, joule per Kelvin. So this is the concept of heat capacity. Now specific heat capacity means what? So amount of heat required to raise the temperature of unit mass of the substance by 1 degree Celsius or 1 Kelvin is called its specific heat capacity. It implies that when heat capacity is divided by mass of the substance, then we will get specific heat capacity. So specific heat capacity, small s, that is capital S by M, that is delta Q upon M delta T, unit will be joule per kilogram Kelvin. So we can rewrite this equation as delta Q equal to Sm delta T. So this equation shows this thing, the amount of heat required delta Q to raise the temperature of m gram substance by delta T having specific heat capacity S, that can be calculated by this equation. Clear to all of you? Now see here, when we say heat capacity, then that is of the substance. But specific heat capacity, that is of the material of the substance, because here we take unit mass of the substance. Let's try to understand this thing with the help of example. Suppose we have a copper coin and we raise the temperature of copper coin by 10 degrees Celsius by supplying some amount of heat. So if we calculate delta Q by delta T, right, then we say that is the heat capacity. And now if heat capacity is divided by the mass of that coin, then we say that is the specific heat capacity. But here, how we will represent this one? Heat capacity of copper coin is equal to this much. But when we represent specific heat capacity, then it is not of the copper coin, but it is of the copper itself. It is of the material. So we represent it like that. Specific heat capacity of copper is this much. Clear to all of you?